Wow,
We are so small. So I guess by saying we don't want to show our faces, we shrunk. This could be a prime example of growth and development.
Well, not exactly. Technically, we didn't grow, we shrunk.
You know what, Selena? Let's just forget it and do the presentation.
Well, first things first. Growth and development of living organisms are not the same things. Growth is the increase in size and mass of the organism. Development involves transformation of the organism as it goes through the growth process.
Then why are they paired together?
Tomato, tomato, I guess.
Well, explain.
Okay, well, think of a baby. It has all the features of a human being, such as arms, a face, and legs, but it's super tiny. As time goes by, they get bigger and become an adult. They still have the same features when they were a kid, they're just bigger. This is growth.
Okay, so what's development?
It's like growth, but much more dramatic. Such as when they are still in their mom's stomach, they start out as a cell or egg, which transforms to a zygote, and then to a fetus before becoming a baby.
So you're telling me that I was one cell before becoming me?
Yep.
Wow. Thank you, tiny cells, for making me.
Yes, and thank you for allowing me to develop my beautiful brown eyes. Wait.
What?
I sort of wonder why the rest of my family has hazel eyes, but my eyes are brown. Honestly, it's not fair. Conspiracy theory.
No, Selena. Actually, it's...
Conspiracy.
Actually, it has to do with hereditary, or better known as the traits passed down to you from your parents.
I'm more of a visual learner, so...
Ugh. Here. This is a Punnett square. A Punnett square is a box split into 4. On both the top and the side, there's a set of letters that represent the traits from your parents.
Does it matter if your mom or dad traits go on top?
No. Anyways, there's a dominant and a recessive trait. The dominant trait is always represented by a capital letter, and a lowercase letter is the recessive trait.
So either letter can go first?
Actually, no. The dominant letter always has to go first. Anyways, to solve this...
Okay, so what does this show me? Like, how do I solve this? And the letters don't make sense. If you don't answer my question, I'm just going to stick with conspiracy theories.
Listen here, Selena. Let me finish.
Oh, okay.
So let's say the letter E represents the color of your mom and your dad's eyes. So, your dad and your mom both have a dominant or recessive trait. You take the letter from the top and the side and put them together.
So the chance of getting brown eyes was 3 to 1. So I was in that 25%.
Exactly.
So I guess I understand why I have brown eyes. I mean, everything makes more sense now.
I guess I'm pretty good at explaining things. That doesn't explain how we were made.
What do you mean?
Well, I know why we have certain traits and that we get them from our parents. But I don't know how we came to be in order to get those traits.
Oh. Well, I think I got that part.
Really? You didn't know hereditary, so you know this.
Trust me, I know. It's called reproduction.
Oh, so continue.
Well, you see, it's when a guy and a girl, you know, they just sort of...
Yeah, please go on.
Ugh. Haven't your parents ever told you about the bird and the bees?
Nope.
Okay, I got this. Alright, it's when, alright, reproduction is the process in which babies are made. Organisms don't need to reproduce to survive, but if they don't want to go extinct, they have to. There are 2 reproduction types. Sexual reproduction, this involves 2 individuals of the same species. The male and female sex cells come together for fertilization to take place. An example is humankind. After this, the newly fertilized cell goes on to become a new organism or baby. Then there's asexual reproduction, which involves only one participant. An example of this is almost all plants. It looks like this.
Okay, but how are we made? Like, specifically us.
Okay, fine, here we go. Yeah, that thing. I think I need some water.
Yeah, I get it now. Oh, speaking of that, let's move on to homeostasis.
What does that have to do with homeostasis? Wouldn't me wanting water be responsive to...
That is for later. But the reason I said that is because due to the embarrassing moment situation earlier, our temperature raised, so to cool us down and maintain homeostasis, we began to sweat, and our hairs are lying down to trap less heat. This is homeostasis. For example, when you're running and your body starts to overheat, your brain tells your body to start sweating to cool down your body temperature.
Okay, so what about when your body gets cold?
So, when your body gets cold, it does many different things. For example, let's say you're walking home from school and you forgot your jacket, and you begin to get cold. Your body can produce goosebumps that are a layer of air around your bodies that perform a protective, insulating layer. Our bodies also flow blood to our internal organs because those are the most important things we need to keep our body moving. There are many more things our body does when reacting to too much heat or too much cold.
Oh, okay, I get it now.
And again, even though I know what homeostasis is and how we maintain it, I don't understand how we came up with the methods for it. I can't control if I sweat or not, or if the hair on my arms lay down. That's on my body.
Oh, I know. We came up, or at least our bodies came up, with ways to maintain homeostasis over time. Specifically, it adapted through time or evolution. I don't remember.
It's adaptation through evolution.
Yeah, it's like growth and development, but over a long period of time. So what happens is that our bodies try to better itself with as little work as possible. So over time, if I notice that we aren't using things anymore, it gets rid of it. Like how we were once supposed to be covered in hair, and now we aren't. That's because our body knows we got other stuff to keep us warm, so there's no use in wasting resources to make it.
That still doesn't explain why we have sweat glands and tiny hairs on our arm that react to our body temperature.
Well, just as our body can take away things, it can give us stuff too. Through random genetic mutations, we are slowly but surely beginning to have different benefits and ways of dealing with things.
What do you mean by genetic mutations?
Well, you know how some people have 6 toes on 1 foot, even though everyone else has 5? That's because of a random genetic mutation. The thing is, usually if the genetic mutation isn't helpful, then it doesn't spread to the rest of the population and dies with the individual. If it's helpful, then it is spread to the majority of species over time.
Then how come people still have 6 toes? Shouldn't it be gone?
Well, it's not harmful to the body, and in today's society, we have the medicine to keep people alive, which in turn keeps the genetic mutation. I was just thinking, how do we maintain life?
That's called metabolism.
What's that?
Metabolism is the chemical process that occurs within a living organism to maintain life. So it is when an organism consumes something and breaks it down, all the molecules to produce energy. That is both the energy we store and use.
Okay, so like when at school, when you're all grumpy and sleepy, then you eat, then you're all happy and sunshine and rainbows?
Yeah, okay. Thanks, Selena.
You're welcome.
Speaking of that, I'm hungry.
I can go for some nuggets.
Dude, nuggets sound so good right now.
Speaking of being hungry, let's go get some food. Wait, one more thing before we go. Did you know that technically by us going to get food, we're improving a feature of life?
How?
Well, because we are hungry, we're responding by going to get food, which is exactly what response to stimuli is.
So responding to stimuli is just something happening and then we react?
Yep.
So if I get cold and as a response I put on a coat, that's a response to stimuli?
Yep, that is exactly right. Now let's go get some food before my stomach eats me alive.